All right, let's have a little bit of a look at the study of mechanics and dynamics. Mechanics itself, well, it's the study of motion of all objects, okay? So it's the motion, the forces that are in play with regarding that motion, whether it's be a driving force or a resistance force or whatever. Dynamics, I guess, is the study of the effects of the forces on the bodies that cause them to move from rest or alter their motion if already moving. So again, they're very similar. I guess again, similar to kinematics, we're studying the motion in a straight line. All right. Our units of force is the Newton. All right, and typically, well, N being the scale. All right, and 1 Newton is, I guess, 1 kilogram weight is G newtons. All right, or GN, 9.8 newtons. So the act of the force relating to gravity. The key process in dealing with our forces and mechanics is to resolve our forces into a common reference plane, I guess, and typically we call that vertically and horizontally. Obviously, we know gravity is acting vertically down, and so then if there's any horizontal motion, okay, we try to define that motion perpendicular to gravity acting down, all right? And we typically use the I and J unit vectors as our directions. So, yeah, let's have a quick look. If we have considered these forces here, find the resolved part of the following force in the direction of EF. All right, so straight up, we've got that 10 Newton force there, which is really, for all intention purposes, our hypotenuse. So there's our 10 Newton force there. So obviously then our adjacent side, cos of 30 adjacent equals adjacent over hypotenuse. So then 10 cos 30 is simply equal to EF, which is 5 root 3. Similarly, for the second diagram here, we've got our horizontal component there. Our hypotenuse component is our 7 Newton force. The adjacent component is the horizontal component. The force is acting from right to left, so it's acting in the FE direction. So cos 60 is in fact equal to FE over 7. So FE is 7 cos 60, which means EF from our vector notation or our vector knowledge is negative 7 root 3 on 2. All right. Similarly, we have three forces acting here. It's in slightly different directions. So the magnitude of the resultant force. So I guess to get that resultant force, we're looking for the horizontal component, the vertical component, and then the resultant force is the magnitude of that. All right, so obviously we have the 5 Newton force acting horizontally. The component of the 2 Newton force acting horizontally is 2 cos 45. The component acting vertically is 2 cos 45 also. For the 3 Newton force, it makes a 30-degree angle with the horizontal. So its horizontal component is 3 cos 30. Its vertical component is 3 sine 30. So if we evaluate all those and add them, we've got my yellow force acting in a horizontal component. We've got that 2 Newton force acting in a root 2i plus root 2j component. And we've also got the 3 Newton force acting as 3 root 3 on 2i plus 3 on 2j. We add all those up, we get that 9.01i plus 2.91 J newtons. The resultant, the magnitude of that, will give me 9.47 newtons, square root of I component squared plus J component squared. To work out the angle that it's acting in, J component, I component, tan theta is opposite over adjacent, which is what we have there. So it's acting at an angle of 17.9 degrees to the horizontal. All right. Final example there is really just straight out of our vector knowledge. Find the component of the force, 3i plus 2j, that's acting in the direction of vector 2i minus j. So in other words, what component of vector A is in the direction of vector B? And that's just typically our standard vector resolute definition. So what we're looking for is A dot B hat B hat, where A is given as 3i plus 2j, B is 2i minus j. So if we work out B hat, work out A dot B, and then A dot B hat will just give me 4 on 5, 2i minus j. So then obviously if we want to know the magnitude of the force acting in that direction, we take the magnitude of that vector and apply the different vector knowledge that we have. Okay.